Now let's look at how to handle missing data. When there is no value for a feature in a particular row, we call it missing data. This can happen because there was no observation or the data might be corrupt. Whatever the reason, we need to deal with it. Uh, Previously, we worked with a modified music data set. Now let's inspect the original version, which contains 1000 rows. We do this by chaining pandas dot isNA with dot sSum and dot sort values. Each feature is missing between 8 and 200 values. Common approach is to remove missing observation accounting from less than 5% of all data. To do this, we use pandas dot drop NA method, passing a list of columns with less than 5% missing values to the subset argument. If there are missing values in our subset column, the entire row is removed. Rechecking the data frame, we see fewer missing values. Another option is to impute missing data. This means making an educated guess as to what the missing values could be. We can impute the mean of all non-missing entries for a given feature. We can also use other values like the median or mean or most frequent values. For categorical values, we commonly impute the most frequent values. Note we must split our data before imputing to avoid leaking test set information to our model, a concept known as data leakage. So here is a workflow for imputation to predict song popularity. We import a simple imputer from Scikit-Learn.impute. As we will use different imputation methods for categorical and non-numerical features, we first split them, sorting as x_cat and x_num respectively, along with our target arrays as y. We create categorical training and test sets. We repeat this for the numerical features by using the same value for the numeric random underscore state argument. The target array's values remain unchanged. To impute missing categorical values, we initiate a simple imputer, setting strategy as most frequent. By default, simple imputer expects numpy.nan to represent missing values. Now we call dot fit underscore transform to impute the training categorical features, missing values. For the test categorical features, we call dot transform. For our numerical data, we initiate another impute. By default, it fills values with the mean. We fit and transform the training features and transform the test features. We then combine our training data using the numpy.append, passing our two arrays and x is equals to 1. We repeat this for the our test data. Due to their availability to transform our data, imputers are known as transformers. We can also impute missing a pipeline. We can also impute using a pipeline, which is an object used to run a series of transformations and build a model in a single workflow. To do this, we import pipeline from Scikit-Learn.pipeline. Here, we perform binary classification to predict whether a song is rock or another genre. We drop missing values accounting for less than 5% of our data. We convert values in the gender column, which will be the target, to a 1 if the rock, else 0. Using numpy.where, we then create x and y. To build a pipeline, we construct a list of steps containing tuples with the step name specified as strings and initiate the transformer or model. We pass this list when initiating a pipeline. We then split our data and feed the pipeline to the training data. As with any other model, finally, we compute accuracy. Note that in a pipeline, each step but the last must be a transformer. Now let's create a pipeline to handle missing data and build a model. So here, I randomly generate some data. Here, one value is missed in a weight. So if you see this, I'm using as data frame dot is NA dot sum dot sort values. It is saying that one value is missing. So when we use the here I'm using the mean for strategy. My strategy I'm using the mean. Mean value is this one. So this is the mean value of weight. So that is where I use the simple imputer. Yeah, thank you. We will connect in another session.